Welcome to the video lesson for section 4.5, graphs of sine and cosine. We're going to look at properties of both the sine and the cosine that allow us to graph it and also allow us to transform it based off amplitude, period shifts, and also horizontal and vertical change. Let's get started. To begin with, let's look at some features of our sine graph. We have a generic model of y is equal to a times the sine of bx. For this function, we have a period of 2 pi, and the period is the length it takes our function to go through one complete cycle or one trip around the unit circle. During this cycle, we have a maximum at pi over 2. It gives us the point pi over 2 comma 1. And this is our maximum because that's the largest value the sine will take on. We have a minimum of 3 pi over 2 down here with the value of -1. And again, that's the minimum because that is the smallest value our sine will take on. In addition to those points, we also have three others. We have three intercepts at 0, 0, pi 0, and 2 pi 0. And those are going to be the places where, again, the sine will equal 0. So by using our 3 points, the maximum, the minimum, and then our 3 intercepts, we can sketch a very quick cycle of our sine function. For our cosine function, we have some different features. Again, we have our generic form of y equals a times the cosine of bx, and then we have one cycle for our function. The period again is 2 pi because that is the length it takes our cosine function to complete one trip around the unit circle, or one cycle. During this cycle, we have two maximums. We have one at 0, 1, and then we have another one at 2 pi and 1. Again, because at these locations, this is where the cosine has its largest value. We have one minimum down here at pi, because again, that is where the cosine will have its lowest value of -1. And then this time we only have two intercepts. We have pi over 2, 0, and then we have 3 pi over 2 and 0. So again, these 5 points can help us set up our basic function for the cosine. One thing I want to point out is for your sine and your cosine functions, they have the same 5 x values for their points, but their y values are slightly different, again, based off of what you get from unit circle. So for your x values, we're going to have 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then to complete your point, it is based off of what you get for the cosine or the sine when you evaluate that angle on the unit circle. Let's discuss some of the features of our functions or how we could do some transformations. To begin with, we have the amplitude. And the amplitude is half the distance between the minimum and the maximum of your function. And one thing to kind of point out here is your amplitude is a distance. And since it is a distance, it's always going to be a positive value. The way that we're going to identify our amplitude is by finding our a value, which is going to be located directly in front of your sine or your cosine. And because we have a distance, the a value is going to help us identify amplitude by taking the absolute value of a. So your amplitude, again, is equal to the absolute value of a. One thing to kind of point out, though, is our amplitude will change each one of our ordered pairs. So initially, we had those 5 starting values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we had the corresponding y values. Those y values are going to be amplified by your a value. And so each ordered pair now would be x comma a times y. Okay, we're going to go ahead and try and find the amplitude for these examples. To find the amplitude, we're going to identify our a value, which is the value that is being multiplied by our function, and then use that to interpret what our amplitude should be. So for our first function, if we identify the a value, again, it's going to be the number that's multiplied by our function. Using that to help us identify our amplitude, we're going to have an amplitude of 4. For our second function, we have a negative a. So while this will affect the graph, when we're talking about the amplitude, we want to remember it's the absolute value of that. So it's not -2, the amplitude is +2. And then for our third function, we see, again, we have a negative a value, it's -4. Once again, when we use that to interpret our amplitude, it is the absolute value of a. So instead of a -4, you get a +4. And each one of these values is going to take our graph and it's going to vertically stretch it. It's going to amplify what our minimums and our maximums were. For our second change, we have our period shift. So the period is the length of one cycle for the sine or the cosine. Our normal period, as we discussed, was 2 pi for both the sine and the cosine, but this time your b value is going to be changing your period, and it's going to be the value that is multiplied by your x. So when we talked about our horizontal shifts with our other chapters, we kind of had the inverse effect. If we had a whole number, so let's say b was 3, that would be a horizontal shrink. If we had a fraction like 1/3, that would be a horizontal stretch. And to show that, to find our new period, we have the following formula of 2 pi divided by b. Now, since it is going to be affecting how long it takes to do a cycle, for our new point, we can see we have x divided by b and then a times y. So your b value is going to be affecting your horizontal length or the time it takes to do one cycle, whereas your a value is going to be amplifying your function, making it taller or shorter. In order to identify our period, we first want to make sure we can identify what our b value is. With our first example, your b value again is the number being multiplied by x. In this case, it's going to be 3. And then for your formula, it was 2 pi divided by b. So in this case, it'll be 2 pi divided by 3, which gives us our period. Notice that is definitely shorter than 2 pi, and so our whole function has been horizontally shrunk by a factor of 3. For our next example, again, we're trying to identify what our b value is. In this case, because we have a fraction, our b value is going to actually be 1/3. And since our b value has the inverse effect on our function, a 1/3 is going to be a horizontal stretch. So instead of dividing by 1/3, we're actually going to be multiplying by 3, and we end up getting a new period of 6 pi. And then for our last function, again, we want to identify our b value. In this case, your b value is going to be 5. And we would again use our formula, which was 2 pi over b. If I divide 2 pi by 5, I just get 2 pi over 5 as my new period, which again is going to be a horizontal shrink for that function. Okay, we're going to attempt to put it all together now and sketch out some graphs by identifying our amplitude and our period change. For our first function, I want to identify any new variables that I might have. In this case, I have an a value of 3. My b value is 1, so there's not going to be a period change, just an amplitude. Since it's a positive 3, we're not going to be worrying about flipping across the x-axis either. So my amplitude, based on my a value, is also going to be 3. My initial maximum for the sine function occurs at pi over 2, and it normally had a maximum value of 1, but that 1 is going to be multiplied by my a value, which is going to be a new maximum of pi over 2, comma 3. For my minimum, that normally occurred at 3 pi over 2, and that had a minimum value of -1, but again, that -1 gets multiplied by our a value, so now I have a -3. The period is going to stay at 2 pi. There is no period change. For your intercepts, the intercepts were 0, 0, pi 0, and 2 pi 0. Because we're multiplying our y value by a, and our y value was 0, your intercepts are all going to stay the same. So we still have intercepts at 0, 0, pi 0, and 2 pi 0. Again, they are staying the same because our y value is 0 for those points, and when you multiply 0 by your a value, it's going to stay. So what I'm going to do now is go ahead and plot those points. I have 0, 0, pi 0, 2 pi 0. Then we have pi over 2 and 3, 3 pi over 2 and -3. And I'm going to connect those dots. And I have graphed one full cycle. If I wanted to graph the original function, again, the only change was our first max was at pi over 2 and 1, and then our min was at 3 pi over 2 and -1. The intercepts were the same. So we can see that our a value, again, that amplitude is going to be a vertical stretch or vertical compression for your function. In this case, because a was 3, we had a vertical stretch. We're going to go ahead and look at a cosine function now. Again, our first step is to identify a and b. In this case, a is 3. B is going to be still 1, so there won't be a period change. Because a is a positive 3, it is also my amplitude. Okay, so I'm going to go ahead and look at what my new points should be. Normally, you would have a maximum at 2 points, at 0, 1, and also at 2 pi, 1. Our y value is being multiplied by our amplitude, so I'm going to have maximums at 0, 3, and also at 2 pi and 3. For my minimum, that occurred at pi, -1, but again, my minimums multiplied by my amplitude, so that's going to be pi, -3. And then for my period, because there is no period change, it's going to remain as 2 pi. Similarly to our last example, your intercepts have a y value of 0. And since that 0 value is multiplied by your amplitude of 3, it's unchanged, which means your intercepts are also unchanged. So we have pi over 2, 0. And then we also have 3 pi over 2, 0. Okay, I'm going to go ahead and graph those points. So we had 0, 3, 2 pi and 3, pi and -3, and then pi over 2, 0, 3 pi over 2 and 0, Oh, my pi is off a little bit. Let me fix that real fast. All right, we're going to go ahead and connect our dots. And for our cosine, it is a curved function, so we're not going to do a straight V. We're going to curve at the top, go down, connect at our minimum, come up, curve at the top again. So again, the cycle keeps going. We've only graphed one cycle. So you don't want to graph a V, you want to graph a curved shape to kind of show that it keeps going. Okay, so for our next function, we're going to have an A and a B value. Your A value is going to be 3. Your B value is going to be 2. Our A value of 3 directly affects our amplitude. And since it's a positive 3, it is also going to be your amplitude. Your B value is going to be a period change. And in this case, it's going to be a horizontal shrink of your period because we're dividing by 2. Your normal period was 2 pi. If I take that and divide by B, then my new period is going to be, it's going to be just pi. So what that means is one cycle will start and end within a length of pi. All right, for our maximum, our sine maximum happened at pi over 2, comma 1. I'm going to write that down. Your new maximum is going to have an amplitude of 3, and it's also going to have a period change by a factor of 2. We're basically multiplying all of our x values by 1/2 or dividing by 2. So if I take pi over 2 and I multiply by 1/2, then I'm going to have pi over 4. So again, that's that period change, that horizontal shrink. And then for our amplitude, we're multiplying it by a, so I'm going to get 3. For my minimum, that happened at 3 pi over 2, comma negative 1. And again, we're going to take our x value and we're going to horizontally shrink that or multiply by 1/2. So I'm going to get 3 pi over 4. And then for my amplitude, it was negative 1. Now it's going to be negative 1 times 3. So we have negative 3. For our intercepts, the y values are going to remain unchanged because we're multiplying them by 0. So they're going to stay the same. But for your x values, they're going to have a horizontal shrink now. So I start off with 0, 0. That one actually is going to stay the same because if I multiply 0 by 1/2, it stays. And if I multiply the other 0 by 3, it stays at 0. Your next intercept was at pi and 0. This time our pi is going to be horizontally compressed by a factor of 2. So we're going to have pi over 2. But we still have a 0. And then for our last intercept, we had 2 pi comma 0. Again, that's going to be horizontally compressed to be pi 0 because we're multiplying our 2 pi by a 1/2. All right, I'm going to go ahead and graph both functions so we can see our vertical and our horizontal changes here. I'll do the original function in blue. So I started off at pi over 2 comma 1. We have 3 pi over 2 negative 1. Then we have 0, 0, pi 0, 2 pi 0. Okay, so that's our normal sine function. We're going to see a vertical stretch and a horizontal shrink. So for our new function, we now have a point at pi over 4 and 3, 3 pi over 4 and negative 3, 0, 0, pi over 2 and 0, and then pi and 0. Okay, so connect those dots. And we can see the A value, our amplitude, was a vertical stretch, and your B value was a horizontal shrink, cutting the whole thing in half. We're going to go ahead and look at a cosine function now with an A and a B value. So for our A value here, it's going to be a positive 2. Your B value is going to be a 1/2. Your A value will be a vertical stretch, and because your B value is between 0 and 1, it's going to be a horizontal stretch as well. So for our period, it was 2 pi. Since my B value is 1/2, I'm going to be dividing by 1/2, which would be the same as multiplying by 2. So when period was 2 pi, it's going to become 4 pi now. Again, because we have that horizontal stretch by a factor of 2. For our amplitude, our A value is a positive 2, so your amplitude is also going to be 2, which means we're going to see a vertical stretch by a factor of 2 as well. All right, for our maximums, we had a maximum at 0, 1. We had another maximum at 2 pi and 1. So for both of those, we're going to multiply our x values by 2 to get that horizontal stretch, and we're going to multiply our y values by 2 to get that vertical stretch, which means we're going to have 0, 2 for our first one, and then 4 pi, 2 for our second maximum. Our minimum was at pi and negative 1. It's going to have the same transformation. We're going to multiply by 2 for the horizontal stretch and then multiply by 2 for your vertical stretch. So I'm going to get 2 pi comma negative 1. Sorry, 2 pi comma negative 2. And then for our intercepts, we're going to see, again, a horizontal stretch and a vertical stretch. So your intercepts were at pi over 2 comma 0, and then 3 pi over 2 comma 0. For our horizontal stretch, we're going to be multiplying both of those values by, both of our x values by 2. So what we're going to see is pi and 3 pi. And then for your y values, we have 0 times our amplitude, which is going to remain at 0. Okay, just like before, I'll go ahead and graph the original function. So we had 0, 1, and then 2 pi and 1. Then we have pi and negative 1, pi over 2, 0, 3 pi over 2, and 0. And we're going to connect again, making sure we have a curved function here. For our new function, we have maximums at 0, 2, and then 4 pi and 2. Then we have a minimum at 2 pi and negative 2. We have an intercept at pi 0 and 3 pi and 0. And I'm going to go ahead and connect my dots. And again, we can see that we have a horizontal stretch by a factor of 2 because of our b value, and a vertical stretch by a factor of 2 because of our a value. In addition to your amplitude, your a value helps you identify if there are any reflections. We have two different scenarios. If we have an a value that is less than 0, meaning it's negative, then the curve is going to be flipped over the x-axis. If instead your a value is positive, then there's going to be no reflection. And we're only going to be focusing on reflections across the x-axis for this course in terms of your sine and cosine functions. One thing to note for your reflections, if you do have one, your minimum will now become your maximum. Your maximum will now become the minimum, but your intercepts are going to stay as intercepts. So just something to watch out for. For our next transformation, we have horizontal translations, which is a shift to the left or the right. And this is going to operate the same way all of our other functions have. If we have a c value that is being subtracted, then we're going to see a shift to the right by c units. If instead we have a c value that is being added, then we're going to see a shift to the left by c units. Let's go ahead and take a look at this. For each one of our examples here, we're going to try and determine if it's shifted, which means you have to identify what a c value is. For our first example, your c value is again the number that is being added or subtracted to your x value. We can see that we are subtracting pi over 3, and since we are subtracting it, that means we're going to have a shift to the right by pi over 3. If instead, for our second example, we have something that is being added, as we see we're adding 2 pi over 3, then that's going to be a shift to the left by an amount of pi over 3, by 2 pi over 3. And then for our last example, we are subtracting pi. Again, when you're subtracting a value, that's going to be a shift to the right. So this time we're going to be shifting to the right pi units. One thing to point out here is that for all of our functions, your b value is 1, meaning there was no period change. If there was a different b value, all of your shifts would be affected by a horizontal shrink or stretch, just like your cycle would, or your x values would be. And we'll see that happen in some future examples. And for our final transformation, we have a vertical translation. This is going to be the number that is added or subtracted to your function itself. So we have a d value here. We can see it is being added or subtracted to the function. If your d value is greater than 0, you're going to be shifting up d units. If instead your d value is less than 0, then you're going to shift down d units. So again, this is going to be a vertical shift up or down. For the following functions, we're going to go ahead and identify any kind of vertical shift up or down, which means we want to identify our d value. For our first function, our d value is going to be this positive 3. Since it's a positive 3, that means we're going to have a vertical shift up 3 units. For our second function, the d value is going to be the negative 2. Since it's negative, we're going to have a shift down 2 units. And for our final function, the d value is the negative 5, which means, again, we're going to have a shift down 5 units. Now that we've talked about our transformations, let's go ahead and try and graph some of these functions. Before we graph our functions, we want to try and identify our a, b, c, and d values here to talk about any kind of shifts that we might have. So for our a value, it's going to be the number that is multiplied by our function. So I'm going to say a is equal to 3. For our b value, it is a number being multiplied by our x. So in this case, b is equal to 1. And that means we're not going to have a period change. So now my period is going to go ahead and remain as 2 pi. For my c value, we're trying to identify something being subtracted to our x value. So my c value is going to be our negative pi over 3. And this means we're going to have a shift to the right by pi over 3 units. And last but not least, we have our d value, which is a number being added or subtracted to our function. In this case, our d value is going to be positive 3, and that means we're going to have a shift up 3 units. Let's go ahead and take a look at what our form of our points is going to look like now. Now that we have all 4 of our values, every point will be something like this. X minus c divided by b, and then y times a plus d. So if you apply changes in this order to all of our original points, we can get our new points. Something that's going to be a little tough though for our x values is we do have fractions, which means we're going to have to consider common denominators. So I'm going to go ahead and do that for my first point, for my minimum. We have 3 pi over 2 negative 1. For my x value, notice I'm going to be subtracting my c value. So I'm going to subtract a negative pi over 3, which ends up making it plus pi over 3. In order to do that, though, I need to get a common denominator of 6, which means I'm going to have 9 pi over 6 plus 2 pi over 6, giving me a new point of 11 pi over 6. And then for my y value, I'm going to have a negative 1 times my a value of 3, and then I'm going to add my d value, which is also 3, which is going to put me at 0. For my next point, I have a maximum at pi over 2. Again, we're going to subtract negative pi over 3, which means I'm going to be adding it. Pi over 2 plus pi over 3, to do that, I'm going to, again, a common denominator of 6. So I have 3 pi over 6 plus 2 pi over 6, which gets me 5 pi over 6. For my y value, again, we're going to be multiplying y times a, so it's going to be y times 3, and then plus 3, which is our d value, which gets me a value of 6. For all of our x-intercepts, we're going to again be adding pi over 3, and we're going to be multiplying our 0 by 3 and then adding 3. So for my first y-intercept, it ends up just being pi over 3, comma 3. For my second y-intercept, it's going to end up being 4 pi over 3, comma 3. And for my last y-intercept, it's going to end up being 7 pi over 3, comma 3. One thing to kind of note here, for your intercepts, the y values are always going to be the same. So once you've calculated one, the other two have to be the same. In terms of graphing this, I have a lot of fractions, and what I'm going to do is I'm going to pick my largest denominator, and I'm going to use that to kind of indicate what my x values are going to be. So to make things easy on me, I'm going to make each one of my tick marks go by 1 pi over 6. That way I can just count off 11 for my first point. So again, my first x value is going to be 1 pi over 6, which means the second tick mark would be 2 pi over 6, and then 3 pi over 6, and so on. So if I want to graph 11 pi over 6, I'm just going to count 11 tick marks and then put a dot. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 11 pi over 6, comma 0. For my next point, 5 pi over 6, comma 6. Again, because of how I set up my x-axis, I'm going to count over 5 tick marks and then go up 6. And my point should be right around there. For my x-intercepts, they are pi over 3, so I can quickly convert them to be over 6. Pi over 3 is the same as 2 pi over 6, so I'm going to count over 2 and then go up 3. 4 pi over 6 is the same as 8 pi over 6, so I'll count over 8 and go up 3. And then for my last one, 7 pi over 3 is the same as 14 pi over 6, so I'll count over 14 and go up 3. And now I have my function, and that is going to show us our shifts. For our next function, we're going to do the same thing. We're going to start off by identifying our a, b, c, and d values, and then use them to help us sketch our graph. So for my a value, it's going to again be the one multiplied by our function. So I have a is equal to 2. For my b value, it is the one that we're multiplying our x value by. So in this case, b is equal to 1. Again, that means we're not going to have a period change, so I'm going to go ahead and say that my cycle is going to be 2 pi. For my c value, it's what we're adding or subtracting to our variable. In this case, c is going to be 2 pi over 3. And that means we're going to have a shift to the left of 2 pi over 3. And then last but not least, for my d value, we're looking for the number that's being added or subtracted to our function. In this case, d is going to be negative 2. And that means we're going to have a shift down of 2. For our function, again, we're going to apply the same thing. So we have x minus c over b, and then we have y times a plus d. So I'm going to be subtracting 2 pi over 3 from all my x values. For my y values, I'm going to multiply by my a, which is 2, and then subtract my d, which is also 2. Let's look at our first point here. If I subtract 2 pi over 3 from pi, again, we have to get a common denominator there. I end up getting pi over 3. And then for my y value, I'm going to multiply a negative 1 times 2, and then subtract 2, so we get negative 4. For my maximum, I'm going to be subtracting 2 pi over 3, which gets me just 2 pi over 3. Sorry, negative 2 pi over 3. And then for my y value, I have 1 times 2 minus 2, which is going to be 0. For my second maximum, we're going to do the same thing. I'm going to subtract 2 pi over 3, which means I have 6 pi over 3 minus 2 pi over 3. Gives me 4 pi over 3. And then we have 1 times 2 minus 2, which is again going to be 0, which is good. Our y value should be the same. For your intercepts, we're doing the same thing. We're going to be subtracting 2 pi over 3. We need to get a common denominator again. This time will be 6. So I'm going to have 9 pi over 6 minus 4 pi over 6, which is 5 pi over 6. And then I have 0 times 2 minus 2, which is negative 2. For my second intercept, I'm going to have 3 pi over 6 minus 4 pi over 6, which ends up being negative pi over 6, comma, negative 2 as well, because my intercepts have to have the same y value. When I graph my values, I want to make sure that I make it as easy as possible. So for my x-axis, I'm looking at my biggest denominator. In this case, it is again 6. So I'm going to make my x values go by pi over 6 again for each one of my tick marks. Again, this means I can just count my tick marks when I'm trying to graph. So for my first point, I have positive pi over 3, which is the same as 2 pi over 6, and then negative 4. So I'm going to go over 2 and then down 4 to put a dot. Then we have negative 2 pi over 3, which would be the same as negative 4 pi over 6. So I'm going to go left 4 and then at 0, so I put a dot. 4 pi over 3 is the same as 8 pi over 6, so I'll count out 8 tick marks. Put a dot. Then we have 5 pi over 6, comma negative 2. And we have negative pi over 6, comma negative 2. When I go ahead and connect my dots, I now have my cosine function. All right, for this next one, I want you guys to go ahead and challenge yourself. I want you to see if you can identify all of the new points, use it to help you graph, and then come back and check and see the completed solution. So go ahead and try that now. All right, let's check out our answer. So we want to identify our A, B, and C values in D. A is going to be negative 5. So this means we're going to have a vertical stretch by a factor of 5. We're also going to have a reflection across the x-axis. B is 1, which means we have no period change. C is negative pi, so we're going to shift to the right pi units. And then D is going to be negative 5, so we're also going to shift down 5 units. When we apply all of those changes, we're going to see we have x plus pi for all of your x values, and then y times negative 5 minus 5 for all of our y values. Looking at what I got for my new minimum, because it got reflected, it actually became a maximum of 2 pi comma 0. For my maximum, those both became minimums. We had pi negative 10, 3 pi negative 10. And then for your intercepts, we have 5 pi over 2 negative 5, and 3 pi over 2 negative 5. And then for your period, it is again going to be 2 pi. Then for my graphing, again, I wanted to make things as easy as possible. So I made all my x values go by pi over 2. So I could just count pi over 2 over for each one of my x values. And for my y values, I went by a value of 5 for each one of my y values to, again, make things easier for me. And this is what my graph ended up looking like. We can see, again, this was reflected across the x-axis, so it's down instead of up. And then we also have our vertical translations as well. All right, guys, that does it for 4.5. Go ahead and get started on the homework, and good luck.